Our new topic is difference between precision and accuracy. Actually, these two terms are so close that to make a difference between them is very much difficult. First of all, precision and accuracy are used in two senses. First, with respect to the readings, and actually with respect to readings, and others is to be to the with respect to the overall measurements or something like that. So let us see what's the difference between precision and accuracy. First of all, how I define precision. Precision I will define in two ways. Number one is actually it is the measurement or reading between two consecutive calibrated lines on the instrument. For example, if you have a meter rule like this one, and you know meter rule, this is suppose 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this 10 millimeters. So the reading between these two, this is known as a precision. So I will say meter rule is precise to 0.1 centimeter or 1 millimeter or 0.001 meter. This is the precision of the instrument is concerned. For example, I can say if a protractor is precise to 1 degree. So that is the precision to which extent a reading is accurate, or reading is closer to that values. So actually it means the reading is closer to that. That's one meaning of the precision. Other meaning of the precision is precise readings means read how much consistent the readings are. How much consistent readings are. Actually, we are least concerned here. It's just the precision of the instrument. We also call this as the least count sometime. Is the precision. Now, precise readings means how much consistent the readings are, or how much close the readings are. You can say that comes in up the precision. For example, suppose that was with the precision is used in two ways. First, with respect to instrument, with respect to the readings. For example, if the value of G in meter per second square is like this one, 9.8, 9.7, 9.8, 9.8, 9.7. It means they are precise since they are close. But suppose this one, suppose 9.8, then 2.4, 14.6, 13.0, or suppose 8.6. These readings are not precise because the readings are not consistent, but these readings are consistent, so they are precise. So that is the actually one thing about the precision. Now let us see what the accuracy is. Now accuracy is, I can say, suppose accuracy is also same thing, suppose to some extent, but the readings are accurate to this one. For example, if something I have recorded, suppose 60 millimeters meter rule, I will say meter rule is accurate to 1 millimeter, or it is accurate to, because it can be measuring accurately to millimeters, so it's accurate to 1 millimeter. That's the accuracy. Another thing is actually what the accuracy is. Accuracy means how much reading is closer to the actual value. How much accuracy means how much reading is closer to the actual value. We are not concerned whether they are precise or not. Accuracy is always concerned with the percentage error. Percentage error is actually actual value minus calculated value divided by actual value into 100. If the less is the percentage error, more is their accuracy. So accuracy is concerned about the exact value, exact things of the things. They can be suppose widespread, but the actual value or average value comes to be closer to that, and that is the accuracy. Now I am giving you an example, suppose, which will be clear, you can understand. For example, we have 4 students or 4 persons, and I am giving them a gun, and they have to suppose hit it in this target. This is the main target. Here is one circle, same circle. They are asked to hit. They are being given 6 bullets, so there are 6 readings. Suppose he is Mudassir. Suppose there's the same target, actually he is Muzammil. Suppose this one, suppose he is Zafar. Same target, they are being given to shoot into that target with the blades, and this is suppose Naveed. Mudassir, Muzammil, Zafar and Naveed, they are asked to hit at these targets. Mudassir has 6 bullets. He actually hits all these 6 bullets here. These are 6 bullets. And Muzammil is hitting all these 6 bullets here. Zafar is hitting some odd bullets. Here. And Naveed is hitting the blades. Naveed is hitting the blades like this one. Naveed is hitting like these blades in this way. These are the 6 blades, and they are, I hope they are clearly shown. These are 6 here. These are 6 bullets here by Muzammil. These are by Zafar. By the way, these are all my own children. Muzammil is my son. Muzammil, Zafar and Naveed are my nephews. So let us see, suppose I have taken just examples for these one. I think they will not quarrel with me for these things. So Mudassir, Muzammil, Zafar and Naveed, they are asked to hit the bullets. Now clearly I tell you, what is the Mudassir? Mudassir is precise and accurate, both. Mudassir is precise and accurate, both. Why he is precise? Because he is consistent in hitting, and he has accurately actually hit the target. So Mudassir is precise and accurate, both. Muzammil is precise but not accurate. Why he is precise? Because he is consistent in his readings. So Muzammil is precise but not accurate. Zafar is, although he has hit 1 bullet exactly in the target, but he is neither precise nor accurate. Naveed is not so consistent, but he is accurate in the sense that he has hit 4 bullets in the target. So I will say he is accurate but not precise. Although he is accurate but not precise. For example, if I can give these values another way, scientifically, for example, suppose I can say he's suppose asked to find the value of g in meters per second square. He have 9.81, 9.80, 9.81, 9.81, 9.80, 1, 2, 3, 4, 5, 9.81. So clearly he is precise and accurate because he has all the values closer to g and he is consistent very much. Now Muzammil is precise but not accurate. For example, he is varying g always like this one. He may have anything. Suppose he is varying g 4.62, 4.52, 4.65, 4.59, 4.60, 1, 2, 3, 4, 5, 4.61. Now these readings are very close, but they are not close to the actual value. So they are precise but not accurate. Now Zafar, what the Zafar is taking, Zafar has one reading of 9.8 meter per second square, or 9.81, 2 decimal place suppose they are varying, 9.81, other suppose he has 12.43, he has 16.49, then he has 2.58, then he has 6.78, 1, 2, 3, 4, 5, and he has 20.23. So you can see he is neither precise nor accurate, because you take the average will not be coming as 9.81. If you take the average will be 9.81. Take the average, this average will not be the accurate value, this will not the, but now see this is Naveed. Suppose he's hitting like this one, g in meters per second square, 9.81, 9.80, 9.81, 9.81, then he takes 7.84, then he is suppose 12.53. Now he may be accurate, his average can be near to the 9.81 meter per second square, but he cannot be precise. So Mudassir is precise and accurate both. So he has less systematic errors, and less random errors also. He has less systematic errors and less random errors. Now Muzammil is precise but not accurate, so he has most probably less random errors, but most probably he has some systematic errors problem. That's why all his values are coming closer. He may have something wrong, less random errors, but more systematic errors. Then Zafar, he may have more systematic errors. You cannot judge from this. More systematic errors, and he may have more random errors also. Then this Naveed, he's accurate but not precise. He may have less systematic errors, but more random errors. You can have a debate about this thing, but more or less this will be the case, although it's very difficult to see which type of the error he or she they have. They are male, sorry, they have, because they can have errors due to the system, due to that one. But see, Mudassir is precise and accurate, So it has, he has less systematic errors and less random errors. Muzammil, Muzammil is precise but not accurate, so less random errors and more systematic errors. Zafar has more systematic errors and more random errors, and Naveed has less systematic errors but more random errors. Now I will see how the graphs can be plotted. Now we will be plotting the graphs. The graphs will be x-axis, y-axis, and x-axis. Along x-axis, x, this is the physical, it's the value of the physical quantity. I can say value of the physical quantity. Value of the physical quantity, and this will be the number of readings, n. Number of readings will be represented by n. X is the value of physical quantity, and this is the x naught. Suppose I am taking this as an actual value. I will plot, I will sketch the graphs of all those 4 possibilities here. Sorry, I will sketch the graph of 4 possibilities here. There's a number of readings against the value of physical quantity. Now there can be 2 number of readings for same physical quantity. So always these graphs are always in loop. Loop in this way. They're always in loop. So if these graphs are always in loop, now see, suppose if the values are precise, if the values are precise, then loop is narrow. The loop is narrow means values are precise, readings are very close, values are the physical quantities. If values are precise, then loop is narrow. And suppose if loop is symmetrical, about x is equal to x naught line, this line, then the values are accurate, or the thing is accurate. So I will keeping these, I will always sketch the graph of these things. Now there can be various possibilities. Suppose for example it was, I think first he was Mudassir. Okay, let's see Mudassir. And suppose for example for the shooting purpose, Mudassir has all 6 bullets here. So Mudassir, he was precise and accurate both, and he has less systematic errors and less random errors. When he has less systematic errors and less random errors, then suppose I am plotting a graph here, how the look will be. This is the x, value of physical quantity, this is n, the number of readings, and this is x naught, the actual value, this is actual value, this is value of physical quantity, and this number of readings. Since he is accurate and precise, so we may have a very narrow loop, and it will be symmetrical, so that the average values are like this one. So this is a simple graph for Mudassir. Mudassir's, these readings are, this loop will be narrower, narrow loop, and this is symmetrical about this line, symmetrical about this line. Hence I can say Mudassir is precise and accurate both, or he has the less systematic errors and less random errors. So this was for the Mudassir, precise and accurate and less systematic errors and less random errors. Let us see what happens for the Muzammil. Now Muzammil was I'm giving you the example of the shooting guard. That's very easy to for the students to learn. Now Muzammil was, this was for the Muzammil. Muzammil was actually, he hit all 6 bullets here. So he was precise but not accurate. He was precise but not accurate, or there were more random, more systematic errors, but less random errors. Now let us see how his graph would be for these 12 values. This is x, are the values of the physical quantities, this number of readings, and this is the average value x naught. Now since he is precise but he is never near to the actual value, so I can make a loop over here, but the loop must be narrower. If the values are less, then this will be the loop, this one. This loop is very much narrower, shows that he is precise, but he is never ever near to the exact value, this exact value. The loop can be here, this is also okay. Or you can have, suppose, loop here, this x, and this is n, this is x naught. Loop can be here also if the readings are more than that one. Suppose if this is 9.8 meter per second, so the value of g, then this he has less values than this. If he has more than this, so both are okay. I'm talking in general term. So precise but not accurate, more systematic errors but less random errors. It means more precise, loop is narrower, but they are near, not near the symmetrical lines. So this was for the Muzammil. Now let us see what happens for Zafar. Now Zafar hit in this way, if I remember. He hit only one bullet in this target, exact in the target, first here, then here, I think hit all 5 bullets here in this way. So he was neither precise nor accurate. Neither precise nor accurate. So he may have a very wide loop and it would not be symmetrical with respect to the actual value. So suppose one way of the graph is this x and this is n, and if this is a symmetrical line, you may have a wide gap, loop here like this one. This is not real to the symmetrical graph, and symmetrical, this is the x naught, okay, and this is not precise, values are spread out. Or you may have like this one, another possibility is also there, x, this is n, and this is x naught. The very wide loop may have here also. So very wide loop. Or if you wish, see, suppose it is not a symmetrical, you can, this is x, this is n, and this is suppose x naught. It can start from here, but it is here. It's not symmetrical about this line, but the loop is wide. Or it may have this shape also. It may have this shape also. So all these graphs are for the Zafar, means he is neither precise nor accurate. Here he has the less value calculated than the accurate value, and here he has actually larger value than the actual value. Here he may have some values closer, but actually all the values are more than that one, and here there are the less values, but some values may have, but they are not symmetrical in either way. So this is for Zafar. Now let us see what happens for the Naveed. Now Naveed actually hit 4 bullets in the target, and he only hit 2 outside. Suppose this is the target. Naveed hit all 4 bullets here, and this one is here, this one, this one. Or he may have here, suppose. I don't remember the actual, but actually this is the case. This is for Naveed, so he was not precise but accurate. So not precise but accurate. It's Naveed, and he may have less systematic errors but more random errors. So if less systematic errors but more random errors, so this was suppose x is here and is here, and this is x naught value, actual value of the physical quantity. He's not precise but is accurate. So the loop will be symmetrical but it will be widespread. The loop will be symmetrical like this one. Now if you have this area will be same but it's wide. So loop is symmetrical and it is wide, means he's not consistent in his readings, but he will have the accurate value, that one. So see, you can see accuracy is that which is very near to the actual value, and precision refers to the consistency. If something is consistency, if you are consistent, it means precise. If you are near the accurate value, it is the accuracy. So that is the difference. But see, precision is another value, another meaning with respect to the instrument is concerned, where it is the least count of the instrument. So we can say, suppose the precision of a meter rule is 0.1 centimeter. That's another case also. So we discussed the precision and accuracy here, and I hope you can understand it.